This tutorial is a quick review of chapters 5.6 and 5.7. Before we can talk about how to solve word problems, we have to make sure that we're very comfortable solving quadratic equations that are just written out in the form that I have on the screen here. I have the binomial x minus 1 times the binomial 5x plus 4 equals 2. So let's work through our steps to solve this quickly. We have to always make sure that if we're solving a quadratic, it has to be set equal to 0. Right now it's set equal to 2, so we're going to have to draw the 2 back over to the other side and combine like terms. But first, in a problem like this, we must first distribute our two binomials and multiply them together. Now I can combine my like terms, bringing my 2 over to the left side of the equal sign by subtracting 2. Now that my quadratic is set equal to 0, I can factor and solve by using the principle of zero product. Let me check my work. I'd get a positive 5x squared and a positive 5 and a negative 6x will give me my negative x. That's going to work. So now I have either x plus 1 equals 0 or 5x minus 6 equals 0. And when I solve both of these linear equations now, I can get x equals negative 1 or x equals 6 over 5. If you have trouble doing problems like that, make sure you practice those before you start the word problems. So before we can solve word problems, let's look at all the formulas we must know. These must be memorized so that whenever we see a problem, we can diagnose which formula we'll use to help solve the quadratic equation. In the yellow box, we have the area of a rectangle is the length times the width. The area of the triangle is 1/2 base times height, or 1/2 length width. And the Pythagorean theorem is a squared plus b squared equals c squared. Notice also at the bottom I have consecutive integers, our x and x plus 1, and then the difference between those and consecutive even and odd integers. So take note of this screen, make sure you understand this. Let me very quickly talk about the Pythagorean theorem again. We've talked about this in class. But the Pythagorean theorem says the length of our two legs, a squared and b squared, has to equal our c squared. The length of our hypotenuse squared. Remember, our hypotenuse is the side opposite of the right angle. Okay? So in this scenario, I have 3 squared plus 4 squared equals 5 squared, and if I check it, 9 plus 16 does equal 25. That's a proof that it works. Let me show you what it looks like here with our blocks here. This is just a proof that we can use. Our 3 squared here, which is 9 cubes, and our 4 squared here makes the same number of blocks that we create by our hypotenuse. So now that we know these formulas, let's look at 3 different word problems and figure out what type of technique we're going to want to use to solve them. One leg of a right triangle is 1 centimeter longer than the other. The length of the hypotenuse is 5 centimeters. Find the length of each side. So in this problem, it looks like we're talking about the word hypotenuse, and we're talking about 2 legs. So if we're talking about 2 legs and a hypotenuse, we are going to need to use the Pythagorean theorem to solve this. A squared plus b squared equals c squared. Now let's figure out what our 2 legs are going to be. Let's define our variables. My one leg is 1 centimeter longer than the other. So my one leg is x plus 1. My other leg will just be x. And it says my hypotenuse, which is c, is going to be 5 centimeters. Okay, now that I have my a, b, and c, well, before I do that, remember you can always draw a picture too if that helps you. Now we say that the length of our one side, our a, which is x plus 1 squared, plus our b, which is x squared, has to equal our hypotenuse squared, which is 5 squared. Now we should try to simplify this, but we're going to have to combine some like terms first. And the difficult part in this problem is remembering that this x plus 1 squared, this binomial squared, needs to be written out and multiplied. This is x plus 1 times x plus 1 plus x squared is equal to, I'll go ahead and do this, 25. By doing my distribution, I get x squared plus 2x plus 1 plus x squared equals 25. And now I'm just going to continue combining like terms until I can set it equal to 0. Now I have a trinomial set equal to 0, and I'm going to try and factor this, but first I have to take out the GCF. And I factor it. Plus 4 and minus 3. So using the principle of zero product, my solutions will be either 3 or negative 4. Now, negative 4 does not make sense as a solution because we want to find the length and the length of each side. Well, we can't have a negative length, so negative 4 isn't a good solution. So let's state our solution that we have. All right, our one length, leg 1, I'll write it over here, is 3 centimeters, and leg 2 must be 3 plus 1, 4 centimeters. Let's look at two more problems quickly. The one problem states that a triangle is 10 centimeters wider than it is tall. The area is 48 centimeters squared. Find the height and the base. Well, this is our area. We're talking about the area. So it's a triangle, but it's the area of a triangle. So we need to use our area formula. And let's define our variables. It says the triangle is 10 centimeters wider than it is tall. Well, tall must mean our height. And wide must be our base. So let's define our variables. B is wider than tall, so it's x plus 10. And our height has to be just x. And they tell us that the area is 48. Let's plug in all that relevant information to our equation. 48 equals 1/2 base, which is x plus 10, times height, which is x. Now we have an ugly little fraction here that we want to get rid of, and since we have an equation, we can multiply both sides by 2 over 1, or just by 2, to clear the fraction. When I multiply on the right side of the equal sign, they cancel, and on the left side, I'm going to double 48 to get 96. Make sure whatever you multiply on the left side, you do on the right side of the equation. Now I multiply and set equal to 0. At this point in the problem, I need to think about what two things I can multiply together that can give me 96, but that add up to be 10. So I go to my calculator, and I'm actually doing it with you now. Divided by 16. 16 and 6 multiplies to be 96. So I have to get x plus 16, x minus 6. And using the principle of zero product, my solutions have to be, x has to equal negative 16 or x equals 6. And let's think about which of these two makes the most sense. We cannot have a height that's negative feet, or negative centimeters in this case. So we cancel that one out. The only one that makes sense is my x equals 6. I plug it back into my solution. My height is 6 centimeters, making my base 6 plus 10, 16 centimeters. Now I've stated my solution. Last one. The length of a rectangular garden is 4 meters longer than the width. The area of the garden is 96 meters squared. Find the length and the width. Here again, we're talking about area, but this time of a rectangle. So we write our formula. Define on our variables. The length is 4 greater than the width. So the width we can just call x. And the area, I'll go ahead and state that, is 96. We have all of our information and we've defined our variables. Let's plug in our information. 96 equals x plus 4 times x. 96 equals x squared plus 4x. 0 is equal to x squared plus 4x minus 96. And again here I have this 96 that I used last time. And I know that 8 times 12 equals 96. And that's what we want to have. So when I factor this, I get a plus 12 and a minus 8 to give me a positive 4. So my two potential solutions are x can equal negative 12 or x can equal 8. Again, since we're talking about the length and the width, we cannot have a negative length or width. So x being 8 has to be our logical solution. Let's state our solution. The width right here is our x. That's 8 meters. And the length equals 8 plus 4, 12 meters. Make sure you review all of these concepts. Make sure you understand when you need to use each formula. Make sure you have this slide memorized so that you know when to have the right formulas. Then define your variables and plug in the correct information. Good luck.